All right, so we just went over simplifying simple rational expressions. Now we're going to move on to the second part of it, which is multiplying and dividing rational expressions. So this is found in 3.2. So if you need to look at a bunch of examples for that, go to the video on 3.2. I already did like a ton of those ones. So all the odds for that. So just go ahead and check those out if you need a little bit of extra practice. So what we need to do when we're multiplying or dividing rational expressions is factor first. We always want to factor every expression that we can to see if we can cancel anything out to simplify it to make life easier for us. So for numbers 3 and number 4, number 3 and number 5 are already factored. Number 4 and number 6 are ones that we're going to have to end up factoring. So number 3 is really easy because we already have all the factors written out. We just need to figure out which ones cancel, because once we're multiplying rational expressions, it all just turns into one big old fraction. So start looking for stuff that cancels in the top and the bottom. I noticed right away that x plus 9 is in the top and the bottom, so those will cancel out. And also the x minus 7s are in the top and the bottom, so those cancel out. So what we're left with is x plus 1 in the top, and then just 3x in the bottom. And here's something that you need to remember, okay? Since this x is adding onto this 1 here, if there's any adding or subtracting in the numerator or denominator, you cannot just simply cancel out the x values, okay? You could if this was x times 1 over 3 times x. The x's will cancel out, and it'll be 1/3. Easy. But they're not multiplying together. They are adding. And since it's adding, it becomes a factor. So the only way that you can get rid of this x plus 1 is literally if there's another x plus 1 in the bottom that you can cancel out with it. So just make sure that you know that. Same thing if I wanted to get rid of this x. If I was multiplying this by x magically, then I could cancel out the x values, but that's not the case. So this is just the simplified expression that we have. All right, moving on to number 4. Number 4 has a quadratic, and then a binomial. But the nice thing is that they're multiplying, so this is all just one big old fraction. All I need to do is just factor all of these little expressions as much as I can and see if anything cancels out, just like in number 3. So for the first quadratic, I need to find numbers that multiply together to be 10, add together to be -7. So those two numbers would be -5 and -2. So this top part so far, I have p minus 5 and also p minus 2. All right, now let's do this factor right here. So I notice that 6p and 24 are both divisible by 6. So if I divide out a 6, I end up with the following. 6p divided by 6 is just regular old p. 24 divided by 6 is going to be 4, so plus 4. All right, so that's all the stuff in the top. Now let's factor the bottom stuff. So I need numbers that multiply together to be 20 and add together to be -12. Those two numbers are going to be -2 and -10. So on the bottom, I have p minus 2 and p minus 10. Now to factor this quadratic, so we need to find numbers that multiply together to be -20 and add together to be -1. Those two numbers are going to be -5 and +4. So in the bottom, this factors to be p minus 5 and then also p plus 4. Once we have all this stuff factored, we can start simplifying it. So we try to find factors that are in common in the bottom and the top and cancel them out. So we have a p minus 5 that's in common, so those go away. P minus 2 that's in common, those go away. And p plus 4 that's in common, so those go away. So the only thing that's left over in the top is the 6, and the only thing that's left over in the bottom is the p minus 10. So that's my simplified expression, because I can't simplify it any further than that. So that's number 4. Now let's work on these two division problems. So division we also did in 3.2. So if you need a little bit of a few additional examples, just make sure that you go over to 3.2. And the back page, they're going to have like 1, 2, 3, 4. I did 4 examples of division, so make sure to check that out if you need a little bit of help for that. But what we do with division is turn it into multiplication. And the way to do that is to keep the first fraction the same. So 6n over 8n squared. Change the sign of division to multiplication, and then flip the second fraction. So this becomes 2n over 3n to the 4th. You might remember it as keep, change, flip, or something like that from when you divide by fractions. But what this does is it turns it to multiplication, which then turns it into one big fraction. Then we can just multiply across the top and the bottom and then simplify it. So pretty easy stuff. 6n times 2n is going to be 12n squared, because n times n is n squared. 8n squared times 3n to the fourth is going to be 8 times 3, which is 24. And then n to the second times n to the fourth gives us n to the sixth power. That's just from the exponent rules that we know about. All right, now let's try and simplify this as much as possible. So 12 and 24, those are both divisible by 12. So this just turns into a 1. This just turns into a 2. And now let's do the n's. So we have n squared, which is n times n. Then I have n to the 6th, which is n times n times n times n times n times n. So I can cancel out 2 n's from the top and the bottom, and I'm left with 4 n's in the bottom. So that's n to the fourth power. So that is my simplified expression right there. So that's number 5. All right, we have one more division problem to work on, and then we'll move on to the backwards addition and subtraction. And it looks like a really hefty bonus problem for number 11. That's probably going to be something like an extra credit level problem. So number 6, again, we keep the first fraction as it is. We change the sign from division to multiplication, and then we flip around the second fraction. So we end up with b squared plus 8b plus 12 over b squared minus 7b minus 18, and then change from division to multiplication, and then flip the second fraction. So b minus 3 in the top, and then b squared plus 3b minus 18 in the bottom. Okay, so it looks like we've got this all set up. It's one big fraction. We need to factor this quadratic, we need to factor this quadratic, and we need to factor this quadratic. This is already a finished factor, b minus 3, so we can leave that alone. But the rest of them we do have to factor. So let's use the x method on all these. So for this one, I need numbers that multiply together to be 12, add together to be 8. That's going to be 2 and 6. So this top part factors so that it's b plus 2, b plus 6. And then we have that other factor in the top also, b minus 3, just from earlier. And then in the bottom, let's see here. So I need numbers that multiply together to be negative 18, and then add together to be negative 7. So that's going to be negative 9 and positive 2. So I get b minus 9, b plus 2. And then this one, it factors, let's see here. So numbers that multiply together to be negative 18 again, but this time add together to be 3, so that's going to be 6 and negative 3. So I have b plus 6 and b minus 3. Okay, everything's all factored. Now let's see what cancels out. So let's see here. B plus 2 cancels out, b plus 6 cancels out, b minus 3 cancels out. And remember that even though it's not here, there's a hidden multiple of 1 on the top. It's always there. So even though everything is canceled out, we still have a 1 in the numerator. And then all this stuff is canceled out except for b minus 9. So b minus 9 stays in the denominator, and that is our simplified expression. So this is multiplication and division. Make sure that you check some of those out. If you need some additional help, it's in the video for 3.2. So that's it for the first page, the front page of the quiz review. Let's move on to the back page now with addition and subtraction of rational functions.